Whirling wheels, symbols of electric power and industry, symbols of the driving force which labors tirelessly to produce useful goods in endless variety from the natural resources with which California is blessed. Along the slopes of the Sierra Nevada mountains and in the principal cities are some 80 hydroelectric and steam-operated generating plants of the Pacific Gas and Electric Company. These plants produce electric power to light the cities, supply the homes of hundreds of communities, and the cities of the central and northern sections of the state. Their combined capacity, together with electricity obtained from other sources, equals the massed power of 2 million horses all pulling together. The whirling water wheels of the mountain hydroelectric station supply most of the drives the wheels of industry throughout the Northern California region. And natural gas, transmitted in huge pipelines radiating from the Kettleman Hills and other fields, serves industry wherever heat and steam are required in manufacturing processes. Profligate Mother Nature covered the slopes of the Sierra and the Coast Range with vast forests which were to play a vital part in the development of California. Our lumber industry today gives employment to tens of thousands of workers in logging camps, sawmills, planing mills, box and cooperage factories, and other plants. Of all the trees of the forest, none appeals more to the imagination than the California redwood. Centuries before American civilization began, majestic groves of sequoia were reaching toward the sky in Mendocino and Humboldt counties and in other favored spots in the Coast Range and Sierra Nevada. Redwood log carried on to supply the constant demand for this valuable lumber, highly prized for commercial use because of its beauty and its resistant qualities against fire and decay. The felled timber is hauled to the mill by logging trains, which dump their unwieldy loads. It takes skill and experience to handle these monsters. From the mill pond, the floating logs are snaked out and hauled to the saw carriage by powerful machinery. Back and forth the carriage thrusts its burden into the saws, which first trim and square the giant of the forest and then reduce it to board and plank size. As the lumber comes from the saws, it is handled by motor-driven cranes and a monorail car and other lifting machinery, which stacks the lengths of redwood into piles ready for shipment or for the planing mill. In this state, where fruit and vegetables and wines are produced in such great quantities, the manufacture of boxes and barrels is an important part of the lumber industry. The ancient art of the cooper calls for skill and experience. The staves are carefully smoothed with a sanding machine. The jointer and pacer is an expert workman, fitting the staves and bottom together so that not the tiniest leak can develop. Then comes the task of hooping the barrel and grooving the top so that when the lid is placed perfectly. Wherever one hears the shrill cry of timber will be found methods of handling heavy loads over rough terrain. Here at a plant on the American River, an aerial tram or electric skip solves the problem of getting the lumber across the deep canyon below. A ride on this high flyer is a thrilling adventure. There's still gold in them there hills. Nearly 100 years have passed since the gold rush days, yet the flow of yellow metal started by the hordes of grizzled prospectors who thronged the streams of the Sierra continues year after year. In the foothill gravel fields, on the banks of mountain streams, and in the quartz ledges deep underground, men still find fabulous riches in California's mines. The modern engine of surface mining is the gold dredge, a monster boat floating in a man-made pool, equipped to scoop the gravel from the depths and separate the heavy gold from sand and boulders by washing and precipitation. The huge steel buckets move on an endless chain, dumping their burden in a revolving drum in which streams of water play. The gold-bearing sand flows down over riffles and plates where the precious metal is recovered. The rocks and coarse material are deposited on moving belts to be carried off at the stern of the dredge to the bank of the pool. These big dredges are mobile. Powered by electric motors, they dig their way relentlessly through the deep fields of gravel which lie along the foothills of the Sierra. Into the depths, deeper and deeper below the surface of the earth, go the miners in search of gold. Many a California mine, once believed worked out, has been extended to lower levels and new veins of gold-bearing quartz discovered. Electric power, used for the operation of the drag line mucker, hoists, air compressors and pumps, ore trains, and ore crushing mills, serves the modern mother-lode workers at every step of the way. In the quartz mine, the gold-bearing vein, once uncovered, is sampled daily to deter the ore being taken out. The hoist and its steel cable provide the lifeline upon which depends the safety of every man who goes down the shaft. After hours spent laboring in the dark, dank underground levels, the crews come off shift, glad to be in the open air again. In Santa Barbara County, near the town of Lompoc, is an example of the endless variety of our state's natural resources. This all-electric power shovel is at work in the world's largest deposit of diatomaceous earth, an immense quarry which covers 5 square miles and contains more than 100 million tons. Electric trains are simply many forms of electric-powered machinery used in quarrying and handling the diatomaceous earth, which is composed of the fossilized remains of diatoms, a vegetable organism found in water. The Lompoc deposit is of marine origin and was formed millions of years ago while the western coastline was rising from the sea. Huge mobile saws cut it into bricks, which are used for industrial heat insulation. The substance is light in weight, porous, highly absorptive, and resistant to heat. If you ever watched the construction of a new skyscraper or the laying of a highway pavement, and who hasn't, perhaps you wondered where the builders obtain the mountains of river sand, gravel, and crushed rock that go into the foundation. Production of aggregates, as these materials are known, is one of the big industries in this region of constant building of projects of every type and size. Extensive plants are required: rock quarries, gravel pits, sand deposits. Huge shovels, derricks, dump carts, rock crushers, washing and screening machinery are employed to collect the different grades of sand and rock in mountainous stockpiles or in loading bins. Much of the heavy work is done by motor-driven machinery supplied from the nearest power line. Manufacture of Portland cement is a major California industry, especially in the central and northern parts of the state, where 7 large plants are engaged in producing this indispensable building material to be used on large projects outside the state in addition to local markets. The work starts in the quarries, sometimes distant from the central mill, where the clay, shales, limestone, gypsum, and other materials that go into the finished product are obtained. In this big plant near Los Altos, a huge shovel burrows into the bank and loads dump carts drawn by tractors. The carts are emptied into a conveyor tram, which transports the material on an endless belt down to the mill. On this belt, 1,000 tons are carried every hour on the long haul to the screening and grinding machines. At the central plant, the cement ingredients are mixed, ground to a powdery texture, and subjected to high temperature in kilns fired by natural gas. At one California cement plant, situated at Davenport in Santa Cruz County, shipment in bulk is successfully handled by transferring the cement a quarter of a mile through pipes from the mill directly into the hold of the ship, moored offshore. The innovation solved a transportation problem and accomplished substantial savings in cost of handling. Strange as it may seem, Portland cement is made at one large plant from deep deposits of oyster shells in San Francisco Bay. Off Redwood City in San Mateo County, the oyster shells are dredged from the bay into waiting barges which carry their loads to the mill at shoreside. And another California plant in the foothills of the Sierra near Jackson is distinguished by its manufacture of the only white cement made west of the Mississippi. An immense rotary kiln, the powdered mixture of nature's limestone and shale, is fused at a temperature of 2,600 degrees Fahrenheit. Modern machinery and science have brought the ceramic art to a high point of efficiency here in the Golden State. Abundant deposits of clays, silica, and other materials used in the making of pottery have aided development of this century-old industry. The list of manufactured articles ranges from building materials, brick and pipe, to richly glazed porcelain wares of great variety. At Lincoln in Placer County is one of the largest pottery plants. In the stockyards of this factory are miles of pipe of all kinds ready for delivery. Its huge gas-fired kilns also turn out molded structural facing, decorative tile, and scores of other items fabricated from clay. In Pittsburg, an entire plant is devoted to the making of fire brick. The clay mixture is fed into an hydraulic press, where it is shaped, cut into brick size, and molded under pressure. The firm label and brand number are pressed into each brick as it passes through the machines on its way to the firing kiln. Many different shapes and sizes of fire brick are made in the kilns of this plant to meet the demand for heat-resistant linings for furnaces, ovens, and fireplaces. Manufacture of tubs, basins, and other bathroom and laundry accessories is among California's largest industries. At Richmond on San Francisco Bay is one of the big factories devoted to these products. The intricate process involves many steps before the beautifully glazed and tinted article emerges from the finishing room. Certain of the forms have a precast metallic base to which the porcelain glaze is applied. Others are made entirely of pottery material in the mold shop, where expert artisans work over the rough casts to prepare them for glazing. Every piece is tested for cracks and flaws before it's passed. Then into the glazing bath it goes to be coated with a fine textured porcelain mixture. During this process, the color is applied, either the standard glistening white or the delicate shades of orchid, rose, mauve, and green that make the modern bathroom something no luxury-loving Roman emperor ever dreamed of possessing. If the finished product survives this rough, bouncing test inspection, it deserves the stamp of approval this worker gives it. From the glazing room, the bowls and basins are loaded on cars which carry them to the big kilns to be fired under tremendously high temperatures created by large natural gas burners. Here is a pottery product seldom seen except at a distance. The huge insulators used on high-voltage electric transmission lines. The big ones look like the inverted mushrooms or saucers. These and many other sizes and shapes of insulators are made for the trade in the Westinghouse Factory in Oakland. 3 different types of clay, each especially selected for its peculiar qualities, are brought to the Pacific coast all the way from Kentucky, Tennessee, and New York. The ingredients are blended and then mixed in the pug mill, as the workers call it. Coming from the mill in a wet mass, the mixture is worked into a rough form by hand, placed in the molds, and completely shaped under pressure and heat in the hot press. After they leave the press, the molds are sponged clean, and under the deft hands of expert girl workers are trimmed of all excess clay. They are then dried preparatory to the glazing process and the final baking in gas-fired kilns. The making of insulators, upon which depends the safety of human life and much valuable property and equipment, is carefully inspected at every step in the process. Every finished insulator is subjected to a high-frequency flashover test to make sure no metallic impurity lessens its quality as a non-conductor of electricity. Of all the industrial products, none offers more fascination than paint. You remember your childhood days when you were given your first box of watercolors and the joy you had in mixing purples, reds, greens, and yellows to rival the rainbow? The appeal of color and the freshly painted surface is common to every one of us, and a visit to one of the big paint factories on the shores of San Francisco Bay offers thrills and interest. Here are extensive laboratories where constant experimenting develops new kinds of paints, varnishes, and lacquers for use in this era of lavish decoration of buildings and furnishings. Here, multicolored pigments are mixed with oils and other ingredients according to formulae worked out in painstaking research. The machines that do the major part of the work are called mills, which grind the mixture between rollers into the smooth liquid color that finally goes into the can ready for use. Value of paint and varnish products produced in Northern California exceeds $35 million annually. In addition to the larger factories, there are many plants in the Bay Area devoted to production of dry pigments, the oils, and other materials used in paint manufacture. If all the articles now made of glass were placed end to end, the line would extend a long, long distance. We even have real glass houses now, and throwing stones is no longer a popular sport. Manufacture of glass products in California includes virtually all varieties and amounts to more than $15 million a year in money value. Because of the multiplicity of our food products, the making of glass containers naturally is a big part of the business. Let's stop at this Oakland factory and see how bottles are made. Sand, soda, ash, and lime, the chief ingredients of glass, are mixed in the batch house and carried to the gas-fired furnace where, under 2,600 degrees Fahrenheit temperature, the raw materials are melted to a syrupy consistency. Crushed glass, called cullet by the glassmakers, is added to hasten melting. One of these furnaces consumes 500,000 cubic feet of this every 24 hours. From the furnace, the molten mass is dropped down to the molds in gobs determined size. The molds are cast iron forms of two designs. In the first, the bottle is partially shaped. It's then transferred to the blow mold, where compressed air blows the still molten glass into finished form. These machines turn out an average of 21 bottles every minute. From this point, the bottles are carried into another furnace, where the glass is annealed and cooled under gradually reduced temperatures. Finally, the finished containers are inspected for flaws and packed in cartons for delivery to brewers, winemakers, fruit packers, and the scores of other manufacturers whose product is packed in glass. From the pictured story of paint and glass products, our camera moves naturally to the chemical industry. The scientist working in his laboratory with test tubes, filters, and retorts has contributed tremendously to the development of modern manufacturing. Chemistry plays a vitally important role in the field of industry. These and other immense chemical plants located in the Bay region contribute to the making of your daily newspaper, your automobile, your household appliances, nearly everything you use. Chemistry has aided agriculture with fertilizers and insecticides, and is doing a great job in supplying the defense industries with vital materials. Chemical processes require plentiful, low-cost supplies of natural gas and electricity, and for that reason, many large plants have been established in the San Francisco Bay region, where abundant salt and seawater, fresh water, and ample transportation facilities are also available. This large establishment produces ammonia, chlorine, caustic soda, and potash, carbon tetrachloride, and dozens of other chemical agents. The single plant, covering acres of ground, employs as much electricity as is needed to serve the entire city of Berkeley. It is a representative example of the several great chemical plants in Northern California, all making their contribution to the march of industrial progress. The salt and brine required in numerous processes are at hand in unlimited quantities on the shores of San Francisco Bay. The familiar towering stockpiles of the white crystals harvested by machinery from sun-evaporated seawater supply the chemical industries in addition to meeting the universal demand for food seasons. Printer's ink, perfected by experimentation and research in chemical reactions, is produced in all its variety of color and substance in this Oakland factory. The pigments, oils, and other ingredients look like paint as they're mixed and ground in mills to serve the manifold uses of the printer's art in the production of your daily newspaper, your books, and magazines. And then there's the vast business of refining petroleum, producing gasoline, kerosene, and a staggering number of byproducts. Along the shore of San Francisco Bay, in Contra Costa County, the hills are dotted with tank farms, clusters of storage reservoirs to supply the refineries and the oil shipping centers in the vicinity. The black gold is pumped to the bay through long pipelines that extend southward and eastward to the oil fields of the San Joaquin Valley. Oil is California's second largest industry, representing annual production of more than $400 million in value. The chemical research departments of the oil companies are contributing more and more to the progress of American industry, and at this time to the program for national defense. Extensive refining plants are operated here by the Shell, Union, Tidewater Associated, and others of the big companies. Here's the big Shell plant at Martinez, where the intricate cracking processes extract gasoline of various grades from the heavy crude oil. Note the electric motors in the midst of the maze of pipes and machinery. Both electricity and steam are used extensively in the refining of oil. At the appropriately named town of Oleum, the Union Oil Company maintains a refinery. The panorama of towers, tanks, pipelines, and steel structures to be seen from the hilltops is a stimulating sight when it's remembered that California's oil fields and refineries, with their vast supplies of oil and gas fuel for ships of the air, ships of the sea, and for the motorized divisions of our Army, are a part of the very foundation of our nation's machinery of defense. From Oleum, we journey on to Avon, headquarters of the Tidewater Associated in its refining operations. The high steel structure in the background is the new steam-operated generating station of the Pacific Gas and Electric Company. This powerhouse, completed in December 1940, represents the latest scientific advances in generating electric power by use of high-pressure steam turbines. Its installed capacity is 67,000 horsepower. There are similar plants adjoining the refineries at Oleum and Martinez. These three powerhouses, which are a part of the Pacific Gas and Electric Company's chain of interconnected generating facilities, were constructed at a total cost of $15 million under a novel cooperative agreement with the oil companies. Waste byproducts from the refineries are used as fuel for the generation of electricity and the production of steam. And the oil companies, in their turn, use a heavy load of electric power to drive their machinery. By this economical arrangement, both the oil companies and the utility derive benefits which enable them better to serve the industrial world with fuel and power. We live today in a world of steel. Steel, the backlog of civilization in times of peace, the mightiest instrument of defense in time of war. In San Francisco and in the cities of the East Bay and at other points in Northern California are numerous plants manufacturing steel and fabricating steel products. One of the largest of these is at Pittsburg, where pig iron brought from Utah is converted into steel, and where rolling mills and molds turn the steel ingots into products for countless uses. Immense quantities of scrap iron and scrap steel are used by Pacific Coast furnaces. First step in the refining process is the melting of pig iron, scrap steel, and burnt lime in an open hearth furnace. 6 of these furnaces are operated in Pittsburg. Each of the 4 largest has a capacity of 65 tons. Under the terrific temperature of about 3,000 degrees Fahrenheit, created by burning natural gas and atomized crude oil, the iron and scrap are converted to a molten mass. Constant tests of samples are made by the operators. The batch must contain the right proportion of the chemical ingredients of the quality of steel desired. Materials are added during the heating process as indicated by the laboratory test. At last, the heat, as it is called, is ready to be poured. But first, the immense ladle, which has been preheated by natural gas torches, is swung into place by an overhead traveling crane. No 4th of July fireworks can equal this spectacular performance. The furnace is opened, or tapped, as the steel men say, and the liquid steel flows into the mammoth ladle. Sparks and fly in all directions. First comes the pure steel, and then the slag, which overflows into the earthen pits below. The brilliant show goes on as the giant crane moves the ladle to the ingot molds, standing ready to receive the liquid metal flowing from an opening in the bottom of the ladle. In an inferno of heat and shooting fire, accompanied by a tremendous rumbling noise, the stuff fills the molds one by one until the ladle is empty. When the poured masses have cooled, the molds are lifted free, and the ingots of steel are ready for further processing in the rolling mills. To convert the steel ingots into useful products involves reheating to a high temperature and rolling the steel into rods and bars and sheets. In the rod mill shown here, the metal is shaped for the manufacture of wire, nails, and bolts. The workers handle the white-hot billets and rods with sure skill and speed. There can be no slip here without danger of injury to the men and loss of time and material. The steel industry is one of infinite variety. In other plants, like this ironworks located in Berkeley, heavy machinery parts are manufactured. Here again, the metal first is heated in a great furnace before it is shaped by giant hammers and presses. This view shows a step in the making of an engine crankshaft. An electric crane transports the heavy weights from the furnace to the 60-ton press. In an Oakland plant, different grades of steel and metal alloys are produced for casting into the 1,001 sizes and shapes used in manufacturing. An electric arc furnace of 10-ton capacity is used. Throughout the melting process, tests are made to keep the mixture up to the specifications of the formula being used. The cameraman has recorded here the making of carbon steel. Then on to a San Francisco plant where dies and machinery are fabricated for use in the manufacture of cans. Electric furnaces supply the heat for these intricate processes which anneal and case harden the dies. And so the work of the steel industry goes on in mills and forges and shops, large and small, all teeming with activity to supply the ever-increasing demand for the machines, the engines, and the instruments of industry. Ships and more ships to help replace Britain's losses of tonnage in the Battle of the Atlantic. Ships to transport America's cargo of airplanes and tanks and foodstuffs. Ships of war and ships of commerce, all desperately needed. The shipbuilders of the San Francisco Bay Area met the emergency with yards and ways and dry docks scattered all the way from Hunter's Point to Mare Island. Ship projects on San Francisco Bay are numerous. There's the United States Navy dry dock at Hunter's Point and the immense Navy Yard at Mare Island, yards and ways on the San Francisco shore and at Alameda, Oakland, and Richmond. A night visit to a shipyard is a thrilling experience. Eerie flashes of light come from the electric torches wielded by the masked welders. Their job is to fuse the plates of the ship into continuous steel to form its hull and decks. Over the sides of the big freighters under construction swarm hundreds of men. Welding is the modern method of shipbuilding in place of the more laborious riveting that used to be employed. Electricity does much of the work these days, operating cranes, X-ray machines which reveal possible structural flaws, as well as the hoists and forges that play such an indispensable role in the modern shipyard. When the launching hour approaches, all stand by to watch the maiden plunge of the new hull. The crowds of spectators, the yards of colorful bunting, the band playing, the blocks are knocked away, and slowly the new ship starts its slide to the welcoming waters of the sea. Another American ship has been launched to carry the stars and stripes to the seven seas. And so on they whirl, these busy wheels that symbolize our industrial activity and prosperity. On and on, providing employment to hundreds of thousands of workers, consuming vast quantities of raw material, creating finished products for the nation's defense, for home supply and for foreign trade. Here you've had a glimpse of some of the plants of the so-called heavy industries, such as steelmaking and shipbuilding. You've seen the chemist, the miner, the lumberman, the oil refiner, toiling with the specialized machinery of their occupation. Important as are their contributions to the business welfare of Northern and Central California, they are, after all, mere flashes against the great industrial background of this magnificently rich territory, rich in untouched raw materials, in geographic location, in expanding markets, in its aggressive, forward-looking people, in its promise of opportunity. And not the least of its riches is the availability of electricity and natural gas, power to drive industry's machines and fuel for industry's furnaces. Tomorrow, as today, they will be ready to serve, to keep in steady, productive motion California industry's whirling wheel.